Muchas gracias por acompañarnos. En breve estaremos arrancando con la presentación número 1 de Schneider Electric.
Let me say first off, hello. Welcome to the Schneider Electric Technology Center. We're here in the Zone 1 of the Critical Power Performance Center. I'm John Gray. I'm the Power Systems Manager here. And for the next 45 to 60 minutes, we're going to be looking at and discussing the Galaxy VX, the topology on that, lithium-ion batteries, and we'll take a look at the Galaxy VM as well. The Galaxy VM and the VX are very similar in their the circuit technology that they use that we deployed with them. It's just a difference of capacity. Okay, so VM is medium size and VX is for large, extra large, right? So let's just start off with some general points about the VX, and then we'll look at the de-energized units that is behind me. So the Galaxy VX is a UPS that expands or grows or scales in 250 kilowatt power cabinets. We start off at 500 kW and can expand all the way up to 1500 in those 250 kilowatt power cabinets. We can actually have 1500 is N+1, so we can have 7 cabinets on that largest UPS, so we can have redundancy built in. But that's scalable all the way from 500 kW and up. So while I'm thinking about it, if there's any questions, you know, let's have this as a dialogue. If I need to slow down or if there's any translation needed, please let me know, and I speak English only, so that's my excuse, but I'll certainly wait for any translation and encourage any questions, okay? So back to the GVX, 500 to 1500 kilowatts in size. The unit can do top or bottom feed, so that's just standard. It's just a matter of an access plate into the input-output cabinet, what we call the IOC. And then finally, there's no rear access requirement on this UPS. So we can push it up against the wall, save space. And then that can translate to more white space in the building versus having to use space around the UPS for access. So everything we're going to be talking about and showing and discussing and demonstrating is really focused on that value proposition. Excuse me. How do we gain the right size from a capacity perspective? How do we scale if we need to? If we put everything in full size day one, how does the efficiency really help me if my load is low or not in the sweet spot? How does this work from an installation perspective and ease of installation and speed of installation? What are we looking at from a maintenance perspective, as well as service interruption, and finally serviceability and sustainability? So everything is focused on how does this help the data center end user achieve better numbers, okay? So let's take a look at the GVX that's de-energized behind me. Now this is a 750 kilowatt UPS. It's got an input-output cabinet, and then it's got 3 power cabinets. We'll take a look at the input-output power cabinet first, the IOC. Now, we have focused primarily on a 1,000 kilowatt and a 1,500 kilowatt input-output cabinet. The 1,000 IOC is roughly the same size as this 750. What I want you to know here is on the left side, and we'll work from the left side over, is down at the bottom is the static bypass switch. Now the static bypass switch, understand I've removed a lot of the dead fronts here so we can have access to see the components On the live unit, these will not be available because it's live and we need to be safe. But the static bypass is right here at the bottom of this part of the cabinet. All the way over on the left side is where our power supplies and controls are for the static bypass. And this is all tied to the main controller that I'll talk about in just a minute. When we pull off the fan door, we're going to see, the first thing we see is the static bypass, the semiconductors for the static bypass here. So these are very modular and can be pulled in and out if required, just by removing a couple screws and bolts to the bus. What I really want to show you on the door are the fans. Now these fans are replaceable while the unit is running. And this static bypass switch can do 125% continuous with one fan gone. I'll show you the removal and replacement of a fan on the UPS that's energized with load, but what I want you to note here is that all the fans are encapsulated on the door, so that it's really easy to access and it can be done while the unit is energized. What we basically have is a screw at the top, and then we have a Molex connector, and then we have a couple ears and some tabs for retention. And that's it. The most important point is that it's 24 volts DC. So that makes it safe, Schneider Electric, as well as safety codes all over the world. All right. So let me stick this back in here, and we'll move right on over to the other side of the input-output cabinet. Now here, this part of the cabinet is a little bit bigger. This is where all our wiring's going into. Right up front, this is where our network management cards go. So we can put two network management cards here. We can parallel these just with network cabling. So it's pretty easy to parallel there if you want to. And we can parallel 5 and a 4N+1 configuration. Now, below this part of the cabinet, or in the bottom part of this cabinet, is the main controller. So this is where all of the distributed controls from the power cabinets as well as the static bypass get tied to this with fiber optics. With the fiber optics give us noise immunity, which is really an advantage in a UPS. Okay, so we don't have any interference with the control systems from EMF. Let me open this up so we can take a look inside. Now, as we go around, I think we're looking over on this side. This is our DC bus. So this is where our batteries are connected. Over here in this right rear corner is the input to the static bypass. So if you're going to do dual mains, this would be the input to the static bypass, and we'll show you the inverter, the rectifier input in just a second. If you're not going to do a single mains, then or a double mains, then we have a single mains kit that ties the bus together, and we'll show you that in just a second. As we move around, output cabling goes right here, and then these three buses right here is where the input cabling goes. Now, we mentioned single mains. If we can see this back here, I'm pointing to, there's busing that goes back here for the single mains kit. And that's unique to this 750 cabinet. On the 1000 and the 1500 IOC, that configuration of the busing is going to be a little bit different, but it's the same idea. It's basically 6 bolts per bus that are installed so that we can tie that input to the static bypass input. Okay? Now, excuse me, a couple other things that we want to look at in here is top and bottom feed, and then where our grounding is. So we're kind of looking down. So here is the ground bar. Now we can do a solidly grounded system or a HRG, high resistance ground. We're seeing more of that in the US. I'm not sure about in Central America, but what we're seeing is older industrial facilities that had a high resistance ground installed already, and we're able to adapt to that. When we look at the very bottom, I want to show you this plate is removed so that we can install cabling from the bottom. And we have a similar plate on top. Now I install everything top feed in the lab, and I know some of you guys have been here to see that, but I'm just kind of showing you there's another plate that goes here, and this is where we land or put, this is where we enter the input-output cabinet for that top feed. Let's take a look over a little bit, move a little bit over to the right, and what I want to show you here is discrete input and output contacts. So we can, this is very, very adaptable. We have some standard points. For example, on generator, that's a pretty important one to have. When we can tell the generator, or tell the UPS, hey, we've got generator supply, so we want to reduce our battery charging so we don't have to size our generator so big. When we're on generator, we can reduce our battery charging, and then when we return to utility, we can go back to full charging on the UPS. And that is like a 0 to 40% of total capacity that we can do recharging at. We want to look at the door. So we're looking at the back side of the door, and this is actually the back side of the HMI, the touchscreen GUI. What I really like to show here is that first and foremost, we have two discrete operator interfaces. This one here goes to an LED with a push button, and this one here goes to the GUI itself. And what's really, really innovative here is that we can replace this touch screen. I'll show you right here. This touch screen can be replaced when the unit is carrying load, because all the controls, I showed you where the main controller is, all the controls are being done there. This is just our interface. So we can replace this while the unit's online. And then we also have this second discrete operator interface. So that's a differentiating factor on this UPS. Let me move down to the power cabinet. It's a 250 kilowatt power cabinet. What I want to do is pull this out, and we'll be able to look at it, show you that there's no rear access required, look inside, do a little bit more on connections. Okay. Let's kind of look at the front. So the fan door is basically the same, except we just cover the entire space for the static bypass. It just covered the fans for the static bypass. This is all the fans in that door for the entire UPS. So the fan is, we have standardized on this fan, not in the Galaxy VX, as well as the VM and the VS that is coming out. So the VS is a smaller unit. It is a 50 kilowatt at 208 volts and 100 kilowatts at 480. We'll talk a little bit about that at the end if we have time. I don't have one installed yet, but we will pretty soon. As we go through the parts and pieces of the cabinet itself, at the very top we have the controller and the power supply for the controller for the cabinet. As we move down, these are the power blocks for the UPS. We got to have 2 per phase. We have copper and fiber connections going up to the main controller. As we move down, this is the rectifier, so this is rated at 250 kilowatts. Phase B of the power blocks. We're going to move down just a little bit more. We'll see the inter-bus connections, okay, that go cabinet to cabinet to the input-output cabinet. power cabinet to power cabinet to input-output cabinet. Phase C of the power blocks. And then here at the very bottom, we have some bolts that go all the way through the cabinet and anchor, they seat into the brackets that anchor the cabinet and UPS to the floor. So let me talk a little bit about that. Let me show you what that bracket looks like, and then talk a little bit about the installation process, because I think this is very important. This is a very easy UPS to install. It's shipped on pallets, so when it gets to site, you know, the installers just have to pallet jack it in place, which is, you know, saves on rigging needs. You don't have to have a forklift. So we pallet jack it in place, then we jack up the pallet itself so we can disassemble it. That equipment comes with the UPS on the pallets. Then we would lower the casters so we can roll it around just like this. You saw this is fully populated. We're about 1,200, 1,400 pounds with this. But what I want to show you is the anchoring system. So this is the back bracket, anchor bracket for this input-output cabinet. Now, we can put this on raised floor, we can put it on slab on grade, housekeeping pads, so very versatile. But what I really want to show you is this conical nut here, okay? So this receives that bolt that goes all the way through from the front. I'm going to flip it so you can see the back side, and it's welded on here. So the first part of the installation is to take these brackets and line them up where you want the UPS to go. Then we start rolling in the individual cabinets. We then start to seat those bolts at the bottom, level it up, raise the casters, and we get until we get a final physical installation. Then we would be installing the bus bar. So let me show you where that bus bar is. I'm going to turn this cabinet real quick. So there's only two points of interconnection from cabinet to cabinet. The first is this bus bar at the very bottom. So we have AC input and AC output. They're stacked. You may not be able to see that. And then the very back is DC. So DC is stacked here. So we have bus links that the field service engineers install. And then the second interconnection is at the very top here. This is where the fiber optic cable that connects the power cabinet controller to the main controller. And that's it. So let me spin this real quick so you can see the back side. So there's no need for rear access. Cooling air comes in the front and then out the top. We do have a clearance requirement on top. The top has to have 55 centimeters clearance, roughly 21 inches, 55 centimeters. You guys don't do English down there, or you do metric? Yeah? Okay. Let me move. I want to spin this real quick so we can just look at the other side. And the importance here is that we can expand this UPS at the cabinet level as long as the input-output cabinet can handle that capacity. So for example, say the data center owner decided that, you know, they want to start at 500 kW, but think that they'll maybe go to 1,000 kW in the future, but want to preserve that capital and spend it when they need it instead of spending it all up front. So we can do that just by making sure the input-output cabinet and all the cabling and breakering is sized for that maximum capacity. And then when that time and that decision is made, we can just ship another power cabinet in, and we basically just set down the brackets and roll it into place. And then there's this panel, right? This covers the the bus works. So there's insulation on the bus, and then this panel, and then we have skins that go on this. So all we would have to do is, we do have to de-energize the UPS, go to maintenance bypass, but just get all this ready, roll it into place, make the connections, button it up. We would do what's called a spot test, so we can internally load bank the connections and make sure everything's working properly, and then put it online. So that's one option as far as scaling to the capacity that's needed. Now, the UPS is also very, very efficient. So at low loads, roughly 30% load is where we start to achieve our 96% efficient. We go up to about 96.4 in double conversion. In E-conversion, which is another operating mode, it's unique to Schneider, we actually achieve a 98.4% efficiency on this unit. So even at low loads, very efficient. So if the customer said, hey, we're going to do it all at once, we can have a highly efficient UPS then, or hey, we're going to expand later, we just don't know when that is, we're good there too, because it's easy to expand and highly efficient as well. So that's kind of that installation piece. That's part of the, some ideas on efficiency. What I would like to do is take a look at the power block itself, talk a little bit about some of the unique features and the innovative technology that we've deployed in this UPS. So let me push this back and grab my cart with the
okay, John.
power block
John.
on it.
Okay, John, do you hear me?
Is there a question?
Yeah.
Questions?
Let us
Okay.
to make a review in Spanish here. Let's. I take the mic to José Alberto.
Sí, bueno, entonces, digo más que nada para no irnos perdiendo de la presentación. Básicamente, entonces, John lo que está haciendo es darnos un speech general de esta línea de productos, de este tipo de Galaxies. Como pudieron ver, el Galaxy es bastante amigable en general. Es un equipo modular. Bueno, es un equipo de capacidad tradicional, pero en crecimientos modulares fijos. Ajá. Entonces, parte de lo que hablaba John es justamente que podemos ir agregando módulos de potencia conforme lo vayamos necesitando, sin necesidad de hacer una inversión inicial fuerte hacia el usuario, ¿no? Sino irla creciendo realmente como lo vamos requiriendo. La conexión es muy sencilla, no necesita acceso en la parte posterior, como pudieron ver, sino que todo el acceso es frontal, y obviamente eso nos permite optimizar espacio dentro del área del cuarto de UPS, y obviamente pues facilitar también el mantenimiento. Si nosotros queremos agregar módulos para crecimiento, lo podemos hacer comprando el módulo adicional que se requiere para el crecimiento y obviamente interconectándolo de forma muy sencilla de la parte lateral del equipo. Ajá. El equipo tiene 3 modos de operación que vamos a ver a continuación y obviamente es una de las tecnologías, o mejor dicho, es la punta de lanza en tecnologías de UPS actualmente. Si quieren, dejamos que siga corriendo la presentación y vemos preguntas hacia el final si tienen alguna. ¿Sí? Please, John, continue.
Okay. So this is a power block for the UPS. And we, Schneider, have developed and deployed a patented 4-level inverter circuit for this UPS. And this is, everybody in the UPS industry is using a 3-level inverter. This is the first, and to my knowledge, the only 4-level inverter in the UPS industry. What is significant about this is that we're able to reduce switching losses across those IGBTs, and that helps us both with efficiency as well as with reliability. Because one of the reasons, or one of the contributing factors to the IGBT and semiconductor failure is voltage stress on the PN junction. And by reducing the voltage, the switching voltage and the switching losses, we're also reducing the voltage stress across that PN junction and extending the life of the semiconductors here. Now, we're looking at a 10-year replacement recommendation on this module, but we're not like looking at replacement of capacitors at a 5 or 7 year interval like we have on the legacy UPSs. When it's time to replace the capacitors, it's going to be done right here. We're going to pull the module out and revitalize the UPS with a new module. So that's really innovative as well. It allows us to minimize service interruption and minimize the amount of maintenance and preventative maintenance that has to be done. Now, a few things that I always like to point out, and what I've learned by working with our R&D team is some of the features of just the power cabinet, this power block and its channelization. When you saw the fans, there's actually 2 fans on each power block. So we're able to channelize the airflow through the block itself, and we've strategically installed components so that what needs the most cooling gets cooling first. So DC caps up front, for example. You can see the heat sinks here, and this is where all the IGBTs are. So this is the front piece. I'm going to spin it so you can see the back as well. And this is where the power block ties into the backplane riser in the power cabinet. Okay, so very easy to install. It's roughly about a 20-25 minute process to replace one of these at that revitalization time frame if everything else is set up right. So the UPS is already in a de-energized maintenance bypass condition. So pretty easy, pretty straightforward to do this. And then just bringing it up online and testing and configuring is all done by the field service engineer and the tuner that they have. Okay? So let me stop right there because I feel like we're at a point where we can actually go and look at the energized UPS that I have here, talk about different operating modes and some additional features. Are there any questions that I can answer or you guys down there can help me with?
¿Alguna pregunta hasta aquí?
Sí. When you do that change, that switch from the UPS, does that imply any downtime or the UPS keeps on working?
So if we have to change these, the power blocks?
Yeah, that one.
So the UPS has to be in a maintenance bypass state. So it's because there's too much energy inside the cabinet. Let's take a look at this again. At the very bottom here is bus bar that connects all the cabinets. And that bus is energized. As long as the UPS is on, that bus is energized. Okay? So in order to get access to one of these power blocks, we would be exposed to that, and that's not, from a safety perspective, we can't do that. So we have to de-energize the power cabinets and be on a maintenance bypass. Did I answer your question?
Yes, thank you.
All right, let's go look at the energized Galaxy VX we have here in the Power Lab. Now this is a 1500 kilowatt UPS. So I want to show you, we've got some lithium-ion batteries on it as well, but this is cabinet 1 of the UPS. So this is power cabinet 1, power cabinet 2, power cabinet 3. Our input-output cabinet actually has 3 doors on it, 1 wide door with our touchscreen GUI here. Then we have power cabinet 4, 5, and 6. Now I've got a little bit of load on this UPS, not very much, about 72 kW. As the load increases, the fans ramp up. Those are DC fans, so they're matching cooling with load. But at some point, it gets a little more difficult to talk over the fan speed. So I've got a little bit of load. the UPS reacts the same with little bit of load or fully loaded. So what I want to show you is we're going to work with the GUI here, but we have two interfaces, as I mentioned. I want to show you the mimic bus. I like this. This gives me a good power flow. So we have the mimic bus here, shows power coming in through the rectifier, charging the batteries, inverter and out, the bypass. Then we have this LED interface here with a push button static bypass inverter button. The little door behind this is where field service engineers would connect with their computer and the tuner. Then there's also a USB port here where the end user, you as the end user, could actually come up and go to the screen for logs. I'll show you real quick. We'll take a look. Logs. Wait a minute. Let me go back so you guys see that. See logs. Go in here. And then we could just go up here to export data. Now, it takes about 15 to 20 minutes to download that file here. It's a real easy step-by-step process guided you right here on the screen. And once that's done, that file can then be sent to our tech support team so that they can be doing analysis related to any questions. And if a field service engineer needs to be dispatched, then they could work in parallel for parts and so on if need be. So let's go back to the screen looking at the mimic bus. We can see the static bypass here, the load. And we're in double conversion now. So I want to show you, excuse me. What I want to show you is that the fans can be replaced while the unit's carrying load. So I'm going to go to one of these cabinets. I'm going to simulate the loss of a fan, and you'll see the alarms that we get, and then we'll show you how easy it is for somebody that's qualified and has access to that power room, how they can replace that fan. And this is really, in my opinion, this is really a phenomenal feature because, you know, on a legacy unit, it can be quite time-consuming and certainly a service interrupting to replace a fan. This one here, the facility manager would look at the morning report. Oh yeah, we had a fan failure. We didn't have any issues with redundancy or backup. Yep, replaced. Just charge on. Really minimize their involvement, and that's certainly something that we want, right? So let's go over here. I'm going to go to, I think I'll go to cabinet 5. That way we're going to look at two screens. So all I'm going to do is disconnect this Molex connector. You can hear the fans ramp up. We should have an alarm on the screen. Yes, we do. So now you would get an alarm, your BMS, your phone. The facility engineer would come down, look at the UPS, say, oh yes, it's the UPS that's got a flashing screen. They would then walk by and identify which cabinet it is, just because the fans ramped up in this cabinet. Then they would have one of 16 fans to choose from, and we've even taken it and isolated it so we can identify which fan has the problem, because we've got LEDs on each door associated with each fan. So the LED that's lit, that tells us which fan is faulty. So we come up with a T20 screwdriver, got our spare fan. Now as you can see, 24 volt DC, so very, very safe. At the top here we've got one screw, we've got the Molex connector, we've got two ears that help retain it at the top, and at the very bottom we got some tabs, so that helps guide it in the right position. There's only one way to put this in. And the last thing I want to show you, this is touch safe. So we've still got load on it. This is the top part of B phase block 2. So we stick it in, make our power connection to the fan, and then we're going to secure it. Our light should go out. So let's confirm that our light has gone out. We can hear the fan ramp down, and we can see on the touchscreen GUI that the UPS is in good operating condition now. Now, for anybody that's worked in the data center world, you know doing that on a legacy UPS is not that easy. Usually happens 2 o'clock on a Saturday morning after you've been partying. All right, let's take a look at the operating modes. What I really want to show you is E-conversion mode, okay? Because this is very, very efficient, as well as it's a unique patented mode of operation that Schneider Electric has for the entire V series UPS. That goes for the VX that we're looking at, the VM, and the VS, which is gonna be ready or introduced in the marketplace September of this year. All right, so double conversion. What I want to do is I'm going to change to E-conversion. Now, E-conversion is a highly efficient operating mode. It performs a power factor correction to the load. It takes about 30 seconds to get there, okay, because we're checking about 150 points in each cabinet. And that information has to be transmitted to the IOC, the input-output, the main controller, and then everything has to be stable before we change. We'll hear contactors open and close. We'll see the screen change. We'll see the LEDs change. And there we go. So we've got a LED change, screen change. You heard the contactors. Now we're in E-conversion mode, okay? And this operating mode gives us class 1 output performance per IEC testing. So I've done a lot of testing on this, and I'm convinced that this is an excellent mode of operation.
Thank you very much.
Thank you. Thank you all very much. Have a great day. I want to extend an invitation for you all to come up here sometime.
Okay, great. Thank you. Thank you.
Bye.